complex numbers. The square root of 4 can be represented, is it not? Because plus 2 into plus 2 gives 4. Minus 2 into minus 2 is also plus 4. And that is why plus or minus 2. Suppose if it is a minus 4, okay, so instead you can write this as plus, that is minus 4 can be written as minus 1, because we can apply the formula root a into root b is equal to root of ab. Split as plus 4 root 2 into root of minus 1. And this root of minus 1 is called the imaginary number I. So root of minus 1 is represented as I. Therefore, that is plus or minus 2 of I, which is nothing but plus of minus 1. Are able to follow? So this actually this I represents iota. So the complex numbers can be represented in this form. Complex number can be represented okay. Some authors they write as ax plus iy also. For example, you can have 3 plus 5i and root of 3 numbers only. Even if you put 2, that is nothing but complex number. A real number can be the entire complex number can be called the universal set. For example, you know the natural number is nothing but the etc. And what about the whole number? That's they start with 0, 1, 2, 3. The integers are represented as, that is starting from minus, you can 3, minus 2, minus 1, 0, 1, 2, 3, etc. The rational number can be represented by P by Q form. Rational number. So when we talk about rational number, you should be aware of irrational number also. So what do you mean by irrational number? The irrational number, they are root 2, pi, root 3, etc. And irrational number can be is terminating if terminating, it will have some pattern that is recurring. For example, when I put 1, 3, etc., so it can be represented as 0.3 bar. But irrational number here non-recurring also. Okay, and that is why we take the example root 2 pi, etc. So inclusive of all, you have got these are all real numbers only. For example, natural number 1, 2, 3, 4, etc. Whole number includes 0, is it not? So that is represented by W. And okay, including integers, rational, even irrational number. Okay, and above that you have the complex number that represent any number by complex number pattern. Okay, the complex number has two parts. Take down. That is a real part, imaginary part. The imaginary, the real part can be A and the imaginary part is B. So generally a complex number is represented as A plus IB, where A represents the real part, B represents, that is associated with I, is called imaginary part. Please make a note. Purely a real number. Purely a real number. In this case, the B is equal to 0. It means A plus IB. So when IB is equal to 0, means that results only A. Okay, so it is called the purely real number. Similarly, purely imaginary number, that can be represented as A is equal to 0. So in that case IB, so here A is equal to 0. So that represents only IB. So that is purely imaginary. Equality of two complex numbers. It means, let me consider Z1, Z2. Z1 is given by A1 plus IB1. Z2 is given as A2 plus IB2. So in that case, when Z1 is equal to Z2, it means A1 is equal to A2, B1 is equal to B2, and that's why they are called equal complex numbers. Next one. Conjugate complex number. Conjugate of a complex number. Conjugate of a complex number. Let me consider Z. Z is pronounced as Z here. Z is equal to A plus IB. And what is the conjugate of this complex number? This conjugate is, that is A minus IB. Okay, and it's represented as Z bar, Z bar. Modulus of a complex number. Modulus of a complex number. It is represented by modulus of Z, which is nothing but, suppose if Z is equal to A plus IB, a complex number, and the modulus is represented as, that is square root of A squared plus B squared. A squared plus B squared. Now let us explain about the algebra of complex numbers. Algebra of complex number. Addition of two complex number. Addition property. Let us consider Z1 is equal to A1 plus IB1. Z2 is equal to A2 plus IB2. IB2. Now the addition is defined as Z1 plus Z2, which is nothing but A1 plus IB1 plus A2 plus IB2, which is nothing but, we can add the real part and the imaginary part separately. So A1 plus A2 plus B1 plus B2 of I. Okay. For example, Z1 is equal to 6 plus 2i. Z2 is equal to 3 minus I. So find out Z1 plus Z2. So we can simply add Z1 plus Z2 is, add the real part, so 6 plus 3, plus add the imaginary part, so 2 minus 1 of I. So that is 9 plus I. Okay. Let us discuss some addition properties. addition of complex numbers. A. Closure property. Closure property. So closure property is Z1 plus Z2. The sum of two complex number results another complex number. The sum of two complex numbers results another complex number. So that also give complex number only. Commutative property. Commutative property means, let me add Z1 and Z2, and you can reverse and add, it will result the same. Z2 plus Z1. So the sum of two complex numbers, whether it is added in a straightforward manner or reversed, it results the same result. Third, associative property. Associative property. Let me consider Z1 as a complex number, another complex number is Z2, and these two are added, then it is added with the third complex number. Now that results Z2 and Z3 can be added, and further it can be added with Z1. Fourth one, existence of additive identity. For example, Z should give the same Z. So in that case, it should be added with a 0. So 0 is the complex number, and that exists as additive identity. So here the additive identity is 0. Existence of additive inverse. Existence of additive inverse. It means if you have got a complex number and if it has an inverse of z, this is plus z, and when you add with minus z, that should result 0. So it means the additive inverse is nothing but minus z. Next, let us discuss about the subtraction of two complex numbers. Let us have z1, a1 plus ib1, z2, a2 plus ib2. So z1 minus z2 is nothing but a1 minus a2 plus I of b1 minus b2. Okay. Example, Z1 is equal to 9 plus 5i. Z2 is equal to 4 minus 2i. Now what is Z1 minus Z2? So Z1 minus Z2 will be, real part can be subtracted, plus this part can be subtracted. So 5 minus of minus plus 2. So therefore 5 plus, you have to be very careful, you got minus here, so minus of minus plus. So I of 7. Okay, so this is Z1 minus Z2. Okay. Next, multiplication of complex number. Let us consider Z1 as A1, I, B1, Z2 as A2 plus I, B2. Now the product is Z1, Z2 is equal to A1 plus I, B1 into A2 plus I, B2. So let us multiply by A2 first. So A1, A2 plus I, A2, B1. Then multiply by IB2. IB2 means A1, I, B2 plus I squared B1, B2. You know, I is equal to square root of minus 1. I squared means squaring on both sides, it becomes minus 1, is it not? So here I squared is nothing but in this case minus 1. So you can replace this I squared by minus 1. Therefore A1, A2 plus I of A1, and you have A2, A1, A2, B1 plus, and what about this? A1, B2, and minus, here I squared is minus 1. So B1, B2. It means A1 minus A1, A2 minus B1, B2 plus I of A2, B1 plus A1, B2. So this is Z1, Z2. And which is the real part? A1, A2 minus B1, B2 is the real part. And the imaginary part will be A2, B1 plus A1, B2. Okay, please make a note of it. Let us work out an example. Find out the product of two complex numbers that is 5 plus 3i and 2 minus 5i. Okay, so we can substitute here Z1, Z2. So Z1 is let us call it, this is A1, B1, A2, B2. So A1, A2 means 5 into 2, and then minus B1, B2. B1, B2 is, that is 3 into minus 5. Is it not? So minus 3 into minus 5, and then plus I of, what is A2? 2. What is B1? 3. So 2 into 3, and then plus A1. A1 is 5 into B2 minus 5. You have to be very careful about the sign. So 5 2s are 10 minus 5 3s are 15. So minus of minus plus I into 2 3s are 6, and then 5 into plus into minus minus 5 5s are 25. So that is 25 plus I into how much? 19 minus 19. So you can get the answer 25 plus minus 19I. This is the answer. So you can put minus here. Okay, so 25 minus 9I. This is the product of the complex number. Okay. Next one. The properties of complex numbers. Multiplication of complex numbers. Properties of multiplication of complex number. Now, closure property. The product of two complex number results complex number. Commutative property. Commutative property. The product of two complex number results when they are interchanged the same result. Associative property. Let us consider Z1, Z2. These are the two complex number multiplied, and then it is multiplied with the third complex number. That is equal to, that is Z1 and the product of Z2 and Z3. It means either Z1 and Z2 can be associative, or Z2 and Z3 can be associated, then multiplied. There is no change of result. It gives the same result. That is called associative property. Fourth one, existence of multiplicative identity. Existence of multiplicative identity. It means, for example, Z should give the same result with which it can be multiplied 1. So 1 is the multiplicative identity. Got it? 5. Existence of multiplicative inverse. So z that should give 1, with which it can be multiplied reciprocal of z. So 1 by z is the multiplicative inverse. Then it can have the distributive property also. For example, let us have z1 and that is multiplied with the sum of z2 and z3. That is z1 plus z3. So that can be distributed as z1, z2, then add with z1 and z3. This is known as distributive property. Now let us proceed with the division of complex numbers. Let us have z1 a complex number, another complex number z2. The quotient z1 and z2, where z1 is the numerator, z2 is the denominator. Normally z2 should not be equal to 0 in this case. So it is defined as z1 into the reciprocal of z2. Example. Find out the ratio between two complex numbers. Six plus 3i and 1 by 3 minus I. Otherwise we can put it instead of 1 by, let us have 3 minus I. Okay. Now let me represent the first complex number as 6 plus 3i. The second complex number as 3 minus I. We know z1 by z2 is nothing but z1 into 1 by z1, z2. Therefore, we can have 1 by z2, which is nothing but 1 by 3 minus I. Am I right? Now, this can be rationalized like this. We can multiply by 3 plus I and 3 plus I. Multiply and divide by 3 plus I and 3 plus I. So that 1 by z2 will be 3 plus I divided by, and you can apply a plus b into a minus b formula. That is equal to a squared minus b squared in this case. Therefore 3 squared minus I squared. You know I squared is nothing but minus 1. Why? Because I is equal to square root of minus 1. I squared means root is removed, so minus 1. Therefore 1 by z2 is nothing but 3 plus I divided by 3 squared 9 minus I squared 1. So minus 1. So minus of minus plus 1. So 1 by Z2 is equal to 3 plus I divided by 9 plus 1. That is 3 plus I divided by 10. Now you have Z1 by Z2. So Z1 is 6 plus 3I and 1 by Z2 is given here. You can replace this by 3 plus I by 10. Are you able to follow? Okay. And now you can multiply this 6 plus 3I and 3 plus I. So 3 into 6, how much? 18 plus 3 into 3I, 9I plus I into 6, 6I, and then 3I into I squared is minus 1, so minus 3. Do you understand? So 18 minus 3, how much? Whole divided by 10. So 18 minus 3, 15, and you have 9 plus 6, 15I divided by 10. So you can take 15 outside the bracket, so which is nothing but 1 plus I divided by 10. So 3 times, and this is 2 times. It means the final answer can be written as, that is equal to 3 of, you can put 3 by 2 of 1 plus I. Okay. Is it clear?